Welcome back, grade 7, to another math video. This one is going to be quite similar to our last one on percentage increase. This time we're just talking about the other way around. What happens if we have a percent decrease? If we have something getting less or getting smaller. For example, you had 100% of a pizza. It had 10 slices. You ate a piece. Now you have a 10% decrease in the amount of pizza that you have, which means you only have 9 slices left. So similar to our other equations or formulas that we used in our last increase video, this time if we want to figure out how much has decreased, we take our original value and this time we subtract it by the decreased value. So I had 10 slices of pizza, now I have 9, which means I had a decrease of 9 slices. Percent decrease likewise is similar to our other equation in that we take our decrease amount that we could figure out right here, we divide it by the original value and times that by 100% because we're looking for a percent. So in this case, there is no difference than our increase, percent increase. It's the exact same formula in how to solve that question. The only difference so far is this little minus sign instead of the plus sign which we had before. A way to figure out decrease value is another way is to take 100% and before we added the increase percent, now we're going to subtract the decrease percent to figure out what's left after we've decreased by that amount and then times that by the original value. So again, these formulas are very, very similar to what we worked with in our last video. Just some minor differences, and most of that has to do with subtracting instead of adding when we're taking a look at a decrease as opposed to an increase. Let's take a look at 3 different examples again. If you feel like you have a good handle on it just using these equations, then feel free to stop this video here and jump right in. Or if you'd like to look through the examples on your own, feel free to do that as well as the pictures are there and you can stop that video here. If you'd like to keep listening and hear the explanations for the examples, feel free to keep listening and we're going to walk through example 12, 13, and 14. Example 12 says, Maria's weight decreased from 140 pounds to 133 pounds. Okay, so in this case, we're given an original value. Her original value is 140 pounds. And we're given also a decreased value of 133 pounds. The question then says, find the percentage decrease in her weight. Well, the first thing we need to do is actually figure out the decrease amount first, and then use that to figure out the percentage decrease. So the decrease amount is just going to be the original value minus the decreased value in order to figure out that that meant a decrease of 7 pounds. Now that we have that amount, we want to figure out the percentage decrease. I'm just going to shorten that to PD. And that's going to be our decrease amount, 7 pounds, divided by the original value, 140, and then take that decimal and times it by 100%. And when we plug that into our calculator, we would see that that represents a percentage decrease of 5%. If we were to finish off answering this question, we would say that Maria's weight decreased by 5% from the original value. Let's take a look at another example here. Let's take a look at example 13. Example 13 says the volume of an ice cube is 150 centimeters cubed. Its volume decreased by 23% after an hour. find the volume of the remaining ice. So we're given the original value again. The original value is 150 centimeters cubed. Don't worry about the centimeters cubed. That's just a unit of value. Really, it's the 150 that we're worried about here. And we also are given the the percent decrease, which is 23%. What we're asked to solve is the decreased value. Find the volume of the remaining ice after that 23% decrease. Now, if we think about from last time, we showed you how there could be two methods to do that. There's a longer way and a shorter way. We're just going to do the second one this time around using this formula here. And that is to figure that out, to figure out the decrease value, we take 100% minus the decrease percent, 23%, times the original value, which is 150 centimeters cubed. So the decrease value equals 100% minus 23% leaves us with 77%. So if we have a 23% decrease, that means that there's only 77% left. I take that, I'm going to multiply that by 150. Now this percent we actually want as a decimal. So decrease value actually is 0.77. Remember, I'm dividing that by 100 times 150 centimeters cubed. Getting close to the end of our page here, but that's okay. All we have left to do is multiply those two values together, and we would be able to figure out that we have a decrease value of about 115.5 centimeters cubed. So what that tells us is that it started off at 150 centimeters cubed, and after a 23% decrease, we're left with only 115.5 centimeters cubed in volume. Okay. Let's take a look at our last and final example here. Example 14. Example 14 reads, the length of a pair of pants is assumed to shrink by 4% after its first wash. So we already know that we're going to be dealing with a percent decrease of 4%. Then it says, if Ben wants to buy a pair of pants that is 102 centimeters long after the first wash. So this is interesting. We now are given a decreased value after the first wash. He wants it to be 102 centimeters long. What we're asked to find out is how long should the pants be when he buys them? What should the original value be so that they end up at 102 centimeters long? In order to figure this out, we are going to use this decrease value formula once again. Decrease value equals 100% minus the percent decrease times the original value. Let's plug in our numbers here. We know decreased value already. That's 102 centimeters. So we're going to have to do some rearranging of our formula here. 100% minus 4%. That's going to give us how much that's dropped, or how much is left, times the original value. That we do not know. Just going to say the original here. We have 102 centimeters equals these two, when we minus them, give us 96%. So the jeans are going to be 96% shrunk. When we take the original value and times them by 96%, we get this lower number of 102. Now, we need this percent as a decimal. So we divide that by 100, equals 0.96 times the original value. And just like we did in our last video, we want to have original value by itself. In order to get it by itself, there's something in the way, the 0.96 multiplied by it. So I want to get rid of that. I want to find a way to move that out of this side of the equation. And my way of doing that is using opposite operations. So the opposite of times is divide. So I'm going to be dividing something here, and I'm going to be dividing this value in order to get rid of it, 0.96. Whatever I do to the right, I have to do to the left. Now on this side, 0.96 divided by 0.96, those cancel out, because if you divide these two, a number over itself just equals 1. 1 times the original value just equals the original value. So they cancel out, and you're left off with just the original value on this side, which is what we were hoping for. And on this side, we're left off with a division question, which is going to leave us with our answer, which is going to be about 106.25 centimeters. Ran out of room for centimeters there, but that means that the original value of the pants should be 106.25 centimeters long, so that after a 4% decrease in value, we end up with pants that are 102 centimeters long. Hopefully this helps you understand better how percent decrease works and how similar it is also to percent increase.